Hi guys, today we're going to be looking at a Euclidean problem for grade 11. We're going to be proving cyclic quads, angles that equal each other, bisecting, and another angle. So when doing these questions, there's a lot of things you need to work through. But I would recommend the first thing is reading the question correctly. So let's look at this question. It says TA is a tangent to the circle PRT, M is the midpoint of the chord PT. They have that written down for us. The center of the circle is O, that is marked. PR is produced to intersect TA, that's drawn for us at A, and TA is perpendicular to PA, that's given for us, and R are joined. OR and OT are radii. OR and OT are radii, which we can see, we can then go and mark on our question that these two lines equal each other. Okay, when working with these questions, it is important if you have a question paper to mark the diagram. It does help when you are working with the question. So I would recommend, if you're going to do this before I do the answers, maybe draw the diagram and then try answering it. So let's get straight into it. The first question is MTAR is a cyclic chord, and we need to prove that. So when looking at MTAR, we're going to isolate here. We're going to be looking at this cyclic quad right here. So what's the closest angle we can find? And we can find these angles here. So we'd now go and say that OMT is equal to 90 degrees. Our reason for that is radii bisects chord. Since we know that OMT equals 90, we can then say that M2 equals 90 degrees. Our reason for that is angles on a straight line. So we now know that that entire section, there's just a bunch of 90 degrees there. So since we know that M2 equals 90 and A1 equals 90, if you add A1 and M2, you'd get 180. So we're going to write that down. M2 plus A1 equals 180 degrees. Therefore, MTAR is a cyclic quad and our reason for that is converse of opposite angles of a cyclic chord. Now, when you're doing these questions, it is also important to note that a previous answer can help you in the next answers, and we're actually going to use that in this question. So let's move on to the next one. We now know that that is a cyclic quad. You can mark it down on your diagram, and then now we're moving on to PR equals RT. So let's look closer at this diagram. We want to know that PR equals RT. So when you know that this line here equals this line here, and if that line equal each other, it would mean that this angle equals that angle. So I'm going to try and prove that T1 equals the angle TPR or angle P. So what I do is I'd first go and look at my diagram. I'd say which angles I can see. And what I can see from here is that I'm going to let P be a variable. And the variable I'm going to let it be is, let's just let P be X. Now if P is X, O1 will be 2X. Okay? We don't know how to get to the answer. We're just going to do the obvious angles. We also know that this right here is a 90. Since this is 2x, we can then do some angles of a triangle and find out what R2 is. Because we know that this angle right here, R2, equals this entire angle here of T, some angles triangle. And if you went and found that they're out, you'd see that this angle right here would be 90 minus x. Okay, so you have 90 minus x. We can also see that this entire angle right here is 90 minus x. This entire angle right here. But before we get there, we're going to see that if we went and used, what other obvious angles can you see? You can see here that T2 will equal P, which would be x. Okay, so we know that this here equals x. And if we did some angles triangle in TAR, we can see this is 90 minus x. And then from there, we can use opposite angles in a cyclic quad and use T1. So this is what I like to do. I like to draw in the diagram, work through the question if it's a bit trickier, see the obvious ones, and then go afterwards and write everything down. If you have another method that works for you, that's perfectly good. Leave a comment down below on what you do. But this is what I like to do. So what I'll say is, let P equal x. Then I'll say that O1 equals 2x. For these questions in this section, there's more than one way of finding the answer. And if you found a better way, you can leave a comment. I love seeing the new ways. This is just the way I found it. Doesn't mean it's wrong. You can still get to the answer as long as you're using the theorems that you've learned. So here we have angle at center equals 2 times angle at circumference. We then worked out that R2 equals OTR, and the reason for that is equal angles, opposite equal sides. And from there we have that 2R2 plus 2x equals 180. We can then divide every term by 2, and then we'll have R2 plus x equals 90 degrees. And then we'll have R2 equals 90 minus x. And the reason for this is some angles triangle. Let's just make all of this a bit smaller. So now that we have this, we know all of those values, we can then say that T2 equals x, and the reason for that is tan quad. We can work out that R2 equals 90 minus x, and we can figure that they out by doing some angles triangle. And then now what we can do is work out T1. So what we'll say is, we'll say R2, oh, this is R3. Okay, I made a mistake here. This is R3. We can now work out what T1 is. So T1 plus T2 plus R3 plus R2 equals 180 degrees, and our reason for that is opposite angles cyclic quad. Now we just sub in the values. So for T1, that is our unknown, so we're going to have plus T2, which is x, plus R3, which is 90 minus x, plus R2, which is 90 minus x, equals 180. And we're going to simplify this now. I'm going to have T1 plus, T1 minus x, okay, plus 180 equals 180. If we then bring the terms onto the other side, you'll now see that T1 equals x. So we've now proven that T1 equals P, which equals x. Therefore, PR equals RT, equal angles converse, equal angles opposite, equal sides. Great. So now if you have all of this taken down, and if we look at our next question after having all of this, let's look at our next question. It says prove that TR bisects PTA. So we're looking at TR bisecting PTA, and that's basically going to say that T1 equals T2. And if you look at our previous ones, we said that T2 equals x, so we can just say proven above. We can say that T1 equals x, proven above. then you'll have therefore T2 equals T1. And that basically means the angles do bisect each other. Now, if we look at our final question, you'll now see that you have T2 is half of O1. So we say that O1 equals 2x proven above, and then we'll have that T2 equals x proven above. So then therefore T2 equals half O1. So something else I wanted to show you guys with this video is that if you did the work in the previous lines of working out in the other question, you can just say proven above. If you've done something, you don't have to do all that working out again. These questions do follow on to each other. I hope this was really helpful, and like and subscribe. If you'd like any more content or something you want to search, leave a comment down below and be sure to make a video. Thank you, all the best guys, and practice, practice, practice.